we get everybody to head back to their tables? We have one last session, and then there'll be lots of time for socializing. I haven't seen him. I'm not sure. So we're going to get going on our last session for the canola industry meeting. My name is Sally Vail, and I'm a research scientist with Agriculture and Agri-Food Canada, and I'm going to be your chair for the last session, and we think Chris Mancher is going to be moderating, so thanks, Chris. So we have a full last session, so we're gonna get going right away. Our first speaker is Mike Harding, who's a research scientist and plant pathologist with the Crop Diversification Centre for the Government of Alberta out of Brooks, and he's going to talk to us about blackleg hotspots and risk prediction.
Okay, thanks very much. Thank you to the organizers for the invitation to be here. I've learned a lot today, and it's been great. I'm going to talk to you a little bit about, sorry, let me go back. I'm going to talk to you a little bit about some work that came out of, my core work with the Alberta government is crop disease monitoring and surveillance. But sometimes that work becomes a bit of a springboard or can feed into collaborative research. And so that's what I'm going to be talking to you about today, is how our blackleg monitoring and surveillance fed into some research activities that were really quite fruitful and enjoyable. Okay, so this is a bit of an outline for what I'm going to do. I'm going to tell you, I think, what my key message is at the beginning and at the end, and then talk about how this idea of blackleg hotspots came about and what it ended up turning into with respect to blackleg risk factors. Okay, so this really would be kind of my take-home message for everybody today, is that with our monitoring work, we're seeing blackleg levels kind of steady. They're not declining. And I think they maybe could, because we have some really great tools to help manage blackleg. And I think this is just a reminder that we have great tools to deal with blackleg. And I think if we continue to use them through scouting and rotation. And when I talk about rotation, I'm talking about both crop rotation and resistance gene rotation. And I think by using these great tools we have available to us, we can stay ahead of blackleg, and I think maybe potentially even get it to decrease or decline a little bit. Now, the numbers I'm going to be showing you are just for Alberta. So this is a graph. On the vertical axis, you have the percent either prevalence or incidence of blackleg, and then on the horizontal axis, years. So this is taking some canola survey data. We have data points in 2012. That was a survey that Ralph Lang led. And then some survey work that my group did from 2015 to 2023. And so you can see it bumps around a little bit. Depends on sometimes what fields we're in that year. We try to be as random and representative as we can. But crop history, crop sequence, weather, these things can all kind of lead numbers to go up and down. So over the long term, though, you can see that the prevalence, or the percent of fields with blackleg, isn't increasing, but the incidence, that's the number of plants with symptoms, is, I mean, it's pretty steady over the years. That blue dotted line is pretty steady, but it's not going down. And so when we were collecting some of these data back in 2015 and 2016 and 17, we started talking with some folks about, occasionally we would see a field of canola that had high levels of blackleg, and why is that? And could maybe some of our monitoring information help us see where, you know, like if there was a virulent race emerging, maybe we could see a hot spot and then, you know, rush in and deal with it. And so this was our hypothesis, that if a virulent race of blackleg was emerging, maybe our monitoring data could help us see hotspots. So we took our data and mapped it, and then in ArcGIS you can tell it to reach out to the 30 points adjacent to it, and then if there's multiple points that have higher than average levels, it'll create a hotspot. And so we did this, and in 2018 and 2019, we looked at these maps and we went, it's not really working. This isn't really telling us much. You can see little sort of spots around that are looking like hot spots, but it's not really working. And so we went back to the drawing board and said, okay, if monitoring data are not informative regarding sort of what I call outbreaks, what risk factors are going to be informative when it comes to blackleg? And so at this point, I'm going to acknowledge the co-authors on the presentation. So that's Dr. Jia Feng, Liang Zhao, Dilantha Fernando, Gary Peng, and Ralph Lang. And also in collaboration with Keith Gaubert, who helped us with this a lot, we came up with a list of things that we would, if we were really going to go after predicting blackleg risk, how would we do that? And so, as good plant pathologists do, we looked to the disease triangle and thought, okay, well, we need to be able to measure the pathogen. So how much inoculum is present? We need to be able to collect weather data, which we can do in Alberta with our Alberta Climate Information Service. And we need to know something about the host. How often is it showing up in rotation? What resistance genes might be present? And other factors. How much disease is present? So we had a look at this and we thought, okay, we want to know how much blackleg inoculum is present in the field. We want to get an idea about the pathogen virulence. What's the race structure? We also want to know what resistance genes are deployed. And then through Gary Peng's work, we also want to look at other predisposing factors like insect damage. And then finally weather. And so we came up with this list of things that we could monitor. And then my crew, along with other collaborators, so my job is to create networks of people that can go out and visit 300 to 400 canola fields in a month. And so we work a lot with the ag fieldmen and with other cooperators. And we developed what we call an intensive, and I apologize that I can't spell intensive. I can do surveys, I just can't spell the word intensive. But our job was to go out to these fields, and we'd go out early in the spring and we'd collect information from the producer regarding, we'd get the location of the field, the cultivar, what was the crop rotation for the last 8 years, so we could know what resistance genes were deployed. We took flea beetle ratings early in the season, and we also collected canola residue from the last time canola had been grown in the field. So the little woody pieces that hang around for 3 or 4 years, we collected those. And then we did a second field visit later in the season, closer to harvest or at swathing timing, and we took disease ratings for blackleg, root maggot ratings, and we collected stem samples for race typing. And then finally, we downloaded weather data. Okay, so this slide's going to get busy now because this is where a whole lot of people came together to do some really interesting stuff. So the first thing that happened was that Dr. Jia Feng at the Plant Health Lab developed a duplex qPCR assay to quantify the amount of Leptosphaeria maculans and biglobosa on the stubble samples. So we now had a CQ value that was representative of sort of how much, and I mean, it's rudimentary, but it was a number that we could quantify and use to sort of predict risk. The second thing that happened was that we took all of these data and we gave them to a postdoc of Dilantha Fernando's named Liang Zhao, and he used artificial intelligence, machine learning, to take all of these data, create and train a model, and then see how predictive it was of the actual blackleg ratings that were collected from those fields. That's the most interesting part, which I'll talk about next. And the other thing I'll talk about today is the race typing. So we send stem samples to Gary Peng at Saskatoon. He determines what races are present, and so we get an idea of what the race structure is for Leptosphaeria maculans, in this case in Alberta, but he does this all across Western Canada. And then finally, we downloaded weather data. And in addition to that, Gary Peng's group was also doing some work with flea beetles, and our data set was a way for his work in small plots to be sort of validated with field data. So there was some interesting information about the effect of flea beetle feeding on blackleg. So in the interest of time, I'm just going to show you some snapshots of things we learned. So this is the relative contribution of different factors to final model predictive accuracy. So how good did the model predict blackleg? And so you can see that when you took all the variables that we evaluated And using the two different models, SVM and CNN, it could predict the amount of blackleg present in the samples about 60 to 70% accuracy, and that was pretty good. So when you took out the root maggot and flea beetle information, the accuracy actually went down. And so when the crop rotation, the accuracy went up, I apologize. So the pest variables, the root maggot and flea beetle feeding, wasn't very informative, or at least not consistently informative about blackleg. But when you remove the rotation variables, so that would be crops in sequence and resistance genes deployed, then the numbers really went down. So with essentially what this told us was that the rotation and the weather could predict blackleg risk to about 70% accuracy. So those are certainly two really big risk factors when it comes to blackleg. And this wasn't necessarily, earth-shattering or mind-blowing, but it certainly confirmed that those are two really important factors when it comes to blackleg. Okay, the second thing that I wanted to talk about today was the regional AVR profiles. And so the next three slides I'm going to show you come from Dr. Gary Peng, and this is work that he does in Saskatoon. We send the stem samples. We just cut a little piece off the symptomatic stem pieces and send them to Gary for this analysis. And one interesting thing that came out of the 2022 data was that AVR LM4 is kind of almost, the numbers are dramatically reduced in Alberta. This is unusual. So I'm going to keep talking about this, but I'm going to show you some maps that Dr. Peng's group produced. So here's a map across the prairie showing where AVR LM7 is present. So the darker the color, the more prevalent this avirulence gene is. And the presence of the avirulence gene elicits the resistance response in the host. So if the AVR gene is present, the resistance is going to work. So this is looking good for AVR LM7. This is the map for AVR LM1. So you can see there's places in Manitoba where this resistance gene is still present, but then absent from a lot of the prairies. And then this is AVR LM4, and this is kind of new information. So these race patterns shift over time, depending on the resistance genes deployed. And you can start to see this absence of AVR LM4 in Alberta. Okay, so what am I trying to say here? So we certainly need to be growing cultivars with an R rating for blackleg. Blackleg's a big threat to canola production, but we have really good resistance, and so we certainly need to deploy it. But because of the shifts in races, we have to be able to stay ahead of blackleg, or it's going to flare up in fields situationally. So we have to scout to make sure it's not flying under the radar and creeping up on us. And then we have to stay ahead of it with crop rotation and strategic deployment of R genes, R gene rotation. Now, I don't have time to talk a lot about this, but R gene deployment, so you can test your canola stubble for what races are present, and then you can deploy an R gene class that's going to be effective against what's in your specific field. And there's a ton of information about this and video tutorials and explanations on the Canola Council's website. So if you want to know more about that, that's where you go to get it. Additionally, there are other tools for really high risk or high pressure situations. Fungicidal seed treatments can help, and an early fungicide application, the 2 to 6 leaf stage. But this really only shows significant efficacy when there's a lot of disease pressure. Okay, so I'm going to wrap this up and just tell you that what we did do just this last year was I had my technician take all of the survey data from 2016 to 2023 and try to create a hotspot map. And now we are starting to see what might be some actual hotspots. So long-term data sets and long-term monitoring of AVR genes and using high-powered statistics and machine learning can help us really understand blackleg risks and what it is that we can do to stay ahead of blackleg. So because blackleg incidence isn't really declining, we need to pay attention to this and stay ahead of it by scouting, testing, and rotating. So in my role, I don't receive funding, but I know that a lot of the work of my collaborators was funded. I don't know if I have a complete list of funders here. I apologize if I don't, but thank you to those of you that fund research. It's so important. And I also want to thank my crew at Brooks and the folks at the Plant Health Lab that help with the monitoring and surveillance of crop diseases. Thank you.
Thank you, Mike, for an interesting presentation that stayed on time. So we do have time for one question from the floor. Oh, can you just pop it to the microphone? Great, thanks.
In your last picture, why was the piece blue and the rest of Alberta was predominantly red?
Oh, so the question is, why was the piece blue and there were other red spots around the province? So the ArcGIS reaches out to look for spots that are above average incidence, and we aren't seeing a lot of above average incidence spots in the fields that we're surveying in the piece. So that's not to say Blackleg is absent in the piece, it's just that we're not seeing clusters of fields close together that have high levels of incidence. They would probably be more scattered. Whereas there's other areas where we're starting now with longer term data sets, we're starting to see areas of the province where there are fields closer together that are developing higher levels of Blackleg. Yeah, great question. Thank you.
Thank you. Thanks again. Okay, so we're going to move into our regular annual reports, and first we're going to be getting an environmental update of the past growing season from Trevor Hadwen, who is an agroclimate specialist in the monitoring forecasting unit of the National Agroclimate Information Services in Regina. So thanks, Trevor, for your recorded presentation.
I hope you're having a great first day of the conference. My name is Trevor Hadwen, and I work with Agriculture and Agri-Food Canada's National Agroclimate Service out of Regina. I have been asked to provide an overview of the conditions through the 2023 growing season. However, before we discuss the 2023 growing season, we must note the conditions leading into the spring. The map on the top left shows the conditions that we refer to through the agricultural year. This includes the fall recovery period, winter snowfall, and the growing season precipitation. You can see that the 1 year prior to the 2023 growing season, as well as the 2022 growing season, to the right, had a couple of notable areas of concern. First off, the wet conditions during this time period in Manitoba, and secondly, the dry areas in Western Saskatchewan. We will discuss both these areas further in terms of the 2023 conditions. The Prairie region generally had below normal precipitation during the fall of 2022, with the central area of Alberta and the northwest agricultural region of Saskatchewan receiving well below normal precipitation. Winter precipitation was a little more scattered, with below normal precipitation throughout central Alberta and southern Manitoba, but average to slightly above average in Saskatchewan and southern Alberta. It is also very important to remember that the Prairie region has been in a dry cycle for several years. Some extremely high precipitation departures and moisture losses have occurred. The maps on this slide show our standardized precipitation and evapotranspiration index, which uses both precipitation and temperature to show relative moisture levels. Looking at the 2023 growing season, precipitation was well below normal in southern Alberta and central Manitoba, and well above normal in west central regions of Alberta. If you recall, the 2022 growing season had significant rainfall, and therefore Manitoba had a greater moisture reserves to withstand the dry periods this spring. The other item of note this spring was significantly warm temperatures, especially in May. Temperatures were 4 to 5 degrees above normal in much of Alberta and western Saskatchewan, as well as through southern Manitoba. This quickly removed any remaining snow early in the month and began to dry the soils. June temperatures were moderated a bit, but remained slightly higher than normal in the eastern prairies. Throughout the spring, drought conditions continued to worsen. In April, drought had been identified in all three Prairie provinces, with the most extensive and most severe drought occurring in central Alberta. In May, high temperatures and precipitation deficits resulted in the expansion of both the extent and severity of drought in Alberta, as well as northwestern Saskatchewan. By the end of June, extreme drought had expanded throughout much of the southern Alberta region, with abnormally dry and moderate drought conditions across most of the Prairie agricultural region. At the end of June, 53% of the agricultural land within the Prairie region was in drought, including 47% of oilseed producers. July and August precipitation was below normal for much of the Prairie region. The map on the upper left shows total precipitation accumulation for these 2 months, whereas the map in the middle shows absolute departure from normal. The map on the upper right shows the precipitation percentiles for this time period. For these 2 critical months, the largest precipitation deficits were in southwestern Manitoba. However, because of good soil moisture reserves from the 2022 crop year, crops in this region seem to be less impacted by the dry conditions than other regions of the prairies. Timing of rainfall is also significantly important for the productivity of crops. 3 locations along the bottom of the slide, North Battleford, Yorkton, and Grand Prairie, show accumulated precipitation throughout the growing season, the red line, compared to the normal, which is the green line, and the daily precipitation, which is in the black bars along the bottom. Long periods of dry conditions are represented by flat or relatively flat periods on the red line. You will notice that throughout these 3 locations, they all received below normal precipitation. However, none of them received long periods of dry conditions. Temperatures over the summer period fluctuated a fair bit. However, generally above normal conditions were experienced in western prairies and below normal conditions in the eastern prairies. The map on the top right shows the number of days during this growing season that had a daily maximum temperature of above 30 degrees. The large regions showing the darker red colors on this map in western Saskatchewan and eastern Alberta had 30 to 37 days above 30 degrees this summer. The bottom 2 graphs show the daily min, max, and mean temperatures throughout the growing season at North Battleford and Yorkton. You may notice on these graphs that temperature occasionally exceeded 30 degrees at both these locations. However, there were limited consecutive events of 30 degrees or more. Drought conditions continue to expand and become more severe throughout the summer as rainfall deficits resulted in poor soil moisture conditions throughout much of the Prairie region. In addition to significant short-term and long-term precipitation deficits, producers were forced to deal with some significant issues, including surface water limitations, limits on irrigation water availability, poor pasture conditions, feed supply issues, poor soil moisture, and crop failures in some regions. By the end of August, 81% of the Prairie region was considered to be in drought, which included 85% of oilseed production. More concerning was that over 20% of the region was in extreme drought, or a D3, the red color on the map, which contained over 18% of Prairie oilseed production. Based on our crop yield forecast model released mid-September, yields were higher in northern and eastern agricultural census regions and lowest throughout the southern areas of Alberta and southwestern Saskatchewan. Comparing these yields to the 5-year normal, it shows that the regions in Manitoba, northwest Saskatchewan, and northern Alberta had yields averaging 5 to 10% above normal, and southern Alberta and southwest Saskatchewan having yields averaging 5 to 10% below normal. As we go into the winter, we have not seen the moisture recovery that we would like to have seen during the fall period. Drought conditions as of the end of October show large regions of the prairies still in moderate to extreme drought, with western Saskatchewan and southern Alberta being the biggest concerns. The map on the top right shows the one-year precipitation percentiles as of the end of October. The map on the bottom right shows the long-term blended index that captures conditions out to 5 years, with weightings heavier on the recent precipitation. All three of these products highlight the concern going into the 2024 growing season. Without significant winter precipitation and large amounts of spring rainfall, drought will continue throughout this region. I'd like to take the chance to thank the organizing committee for inviting me to talk today. If you have any questions, please feel free to email me at trevor.hadwen@agr.gc.ca. And I'd like to remind everyone that all the maps provided in this presentation can be found on the AFC website under the general theme of weather and drought related to agriculture. The URL is there. And again, if you have any questions, feel free to contact me. Thank you very much.
Thank you, Trevor. Unfortunately, we don't have Trevor online for questions, so I'm going to invite our next speaker up, who is Dr. Véronique Barthet. And she's a very familiar face to many of us, giving us our annual seed quality report of the Western Canadian canola crop. But for those of you who are new to the canola community, I just wanted to give you a bit of background in that she is responsible for maintaining the Canadian Oilseeds Quality Assurance Program at the Canadian Grain Commission. So thanks, Bert.
Thank you, and good afternoon, everybody. So actually, that was great to have the speaker previous me, because usually my couple of first slides are talking about the weather, since it's such a big influence on the quality of the crop. So one of the things that was not mentioned, it's the fire and the amount of smoke that were cover a lot of the prairie and a lot of the canola growing area. And to be frank, unfortunately, I don't think anybody has the answer how the smoke is affecting the quality of the crop. Does it block the sun and is less heat? Does it kind of keep more moisture? Anyway, so it's a big question, but that's something that has to be mentioned. A lot of fire, a lot of smoke everywhere. Those slides were produced before. So when you see that, actually, you're wondering how come there is a crop. And one which is very important in this 30 degrees Celsius, actually, if you compare to last year, there was a lot less day over 30 than last year, which is kind of good because it's affecting the flowering. This is also very important for me because every time you have a dip, either a stop, either during seeding or during harvesting, that means that you're going to have an issue somewhere. Especially if it's during harvesting, that means it's going to rain. And if there is rain, that means they're going to be sprouting. So it's an issue. So this year, very similar to last year, except in Manitoba, because there was no flood, there was no rain. So seeding went well, started like not normal, actually, because April was really cold, so seeding was nearly everywhere, if you look at the 5-year average, but it was similar to last year for the seeding and for the harvesting. Something very special, my first canola crop, my first canola sample for the harvest survey came the second week of August. That never happened to us before. And there was a sample from Southern Saskatchewan. So, number of sample, I don't know if you see, but actually, because I cannot see from here, I'm short-sighted and the screen is too small. So the number of samples has been decreasing. I'm not sure why. 2020 was a big number. The reason might have been because there was early snow. Seed was harvested after snowing, after snow in the field, and people might be thinking that actually there was some quality issues, so they send more sample. But it's been kind of decreasing over the last couple of years, and it's an issue, because if you don't have good representation, then that means your harvest survey and your production is not that good. So I don't want to pick on Alberta, but since we were in Alberta, I have the data from Alberta. If we were in Saskatchewan, I will have Saskatchewan. But actually, the return for the sample in Alberta is usually pretty good. But something that I don't understand, and that's the reason why I was looking at the data, if you take the region 4 from Alberta, the production hasn't been changed from this year to last year. But we have, way more sample from one year to another one without much change of production. And I don't understand why. I don't know why. So my goal is to get as much sample as possible and try to understand why suddenly from 1 year I had, less sample, 101 or whatever. And then actually, south of Saskatchewan, there is an area, and I'm talking about Ag Census, the Ag Census 4, there is no sample this year, which is kind of an issue because when the Canola Council is thinking about expanding to the brown zone, there is not enough sample to really look at the quality of what is produced in the brown zone. And that's something that's going to be important. So at one point, if people have an idea about how we can promote the harvest survey and get more sample from the producer, that will be great. Okay, number of samples, and number of samples graded number 1, very similar to last year, pretty good. Actually much higher than last year, but pretty good. Everything higher than 90 is really good. And few of the downgrading was due to heated seed, actually, on the sample grade. The oil content was pretty good. Big increase in the oil content compared to last year. And also, I had a discussion at lunchtime, very close to the 10-year average, which is, when you look at the weather data, and when we heard the previous speaker talking about the lack of water, the degree over 30 and everything, kind of make a story kind of very strange. How come? And actually, that was the slide. This is July in the previous speaker map. July was cooler than normal, and it was cooler than actually last year. And even if you still have number of day higher than 30 degrees Celsius, one of the things was the night in July, and if you look at the ag map, the map in July were really cold. There was a couple of days where actually the minimum temperature was less than 10 degrees Celsius at night. And I think this is the reason why actually we have a very high oil content this year compared to last year, because the whole July month was very cold during the night for most of the prairies. And that's played a big role because the canola had the time to recover from the day temperature during the night. So this is the historic data when you look at 10-year average. And the reason why the 10-year average is actually as good as this year is because the last 2 years of the data are such a big influence of the 5-year or 10-year average that actually, yes, this year we had a 10-year average data. But actually, if you look at the data up to 2019, we're still lower than the oil content average, okay? By about 1%, 0.5% to 1%. So, very good recovery, but still not there to what we were before 2020 when we had the drought and we had the high number of day over 30. So when we have higher oil, still have lower protein, and this is what we have this year. So we had still a pretty good protein content, but lower than last year. And again, if you look at the data over the more than 10 years, 2020, to the oil content average is still higher than what we saw up to 2020, which is pretty good. Could be actually that it's because the oil content is still lower than what we had in 2020, but also might be a result of the WCCRC when it was decided that we were going to increase the protein content by about 0.5%. So that may be a conjunction of the oil having a lower, but not as low as, the oil being higher, but not as high as it was before, and then the action of the WCCRC to push the protein content a bit higher. So glucosinolate, they're very low this year, which is very good news. What's actually way lower than what I was expecting, because my first sample of canola, the one I got early August, was actually 26 micromole of canola, of glucosinolate in the seed. Okay, that was, because it was only 33% in oil, was actually not canola, it was rapeseed. And that was due to the drought condition. The drought is pushing the glucosinolate high, so there is still some variety that higher than normal, but average, it's a pretty good glucosinolate content. And then this year, actually, I'll look at what was the glucosinolate in the meal. Because the protein content of the seed are pretty good, the glucosinolate in the meal, by calculation, not what you're going to have when you crush, but just the calculation, it's lower than normal, just because we have a bit of higher protein, and we have lower glucosinolate. So chlorophyll. Well, chlorophyll is low. It's no surprise. When you have a very nice autumn, when there is no early frost, we had frost at don't know when, end of October, I think, when everything was harvested. So the chlorophyll is going to be low. So this is what we see here. It's nothing related to the genetics, nothing related to the seed. It's just linked to the environment and the growing season that was actually pretty long. Alpha-linolenic acid, it recovered from the dip of the last year and the year before. And again, this is due to the environment and the cool growing condition that you are during the night in July. I don't know if people remember, but if you were driving all over the prairie in July, it looks like the canola was keep flowering and flowering for a long time. And that was because of this cool night. And this is the results that we had in the oil and actually in the alpha-linolenic acid. Again, when you have an increase in alpha-linolenic, you have a decrease in oleic, and this is what we see here. But the decrease is not that much, okay? It's the overall, by the genetics, you still have an increase, a positive increase in the oleic acid in the canola. And then finally, the iodine value. The iodine value is higher than last year because, again, the alpha-linolenic acid is higher than last year, so it's going to push the iodine value higher. And the saturates. The saturate is the only fatty acid, actually, that controlled by breeding. So they control to be lower than 7. And this is what you see over there, that when you have something that actually controlled by the genetics, you're going to have something very stable. And this is what we have here. It looked like a big change, but actually it's a very small one. So this is the overall quality of the crop. It's consider what we had as a growing season, it's pretty good. It's not maybe as excellent as what we used to have, but it's way better than what we have over the last 2 years. And I think we still don't have a good understanding of the effect of the smoke on the crop, but I really believe that the cool night in July actually was one of the things that pushed the quality of the crop the way it is now, or the way it is this year. Just kind of also a pitch to sell the harvest survey. I had a question about what was the difference between the moisture of the seed and the moisture of the dockage, because sometime in the bean you could have pocket of things settling, and then you're going to have pocket of dockage somewhere. And so the harvest survey, actually, it's the best time to run a study like that, and this is what we did. And actually, yes, there is a big difference between the moisture of the seed and the moisture of the dockage. So even if you're going to have only 2% dockage or 2.5% dockage somewhere as a producer, if you have a pocket of dockage somewhere, you could have a big difference in the moisture content of that dockage compared to the moisture content of your seed. And this is something that you can do when you have harvest survey, because we have a lot of samples, and this is only the time that we have a difference between the seed and the dockage, because the seed tend to equilibrate after a certain time. So I want to thank everybody to help to do the harvest survey. And then we changed a bit the things this year. So all the harvest survey reports are just under one headline, and this is the link. And thank you for your attention.
Okay, and we're going to move on to our next speaker, who's Jason Casselman from the the Canola Council of Canada, who is an agronomy specialist out of the Peace River region, and he's also the Plant Establishment, Precision Ag, and Profitability Lead for the Crop Production and Innovation team. So he's going to give a report on the production season from 2023.
Thanks a lot, Sally. And yeah, keeping on with the theme of the weather this year, for sure the canola crop, how it responded to the weather and some of the impacts that we saw from the growing conditions. So this is each one of these dots is a canola field in Western Canada, and it represents about 150,000 canola fields in Western Canada. And so you can see where the concentration of our canola crop comes from, and where each of those dots grows a canola field. So when we talk about that brown soil zone, it is that kind of that underrepresented area in Alberta and Saskatchewan. That's kind of a hole there. So maybe there's opportunity to expand canola into some of those areas, but keeping canola in our fields. So if you look at the Stats Can report, this is the numbers that came out yesterday on what we've got for canola crop, and it is unfortunate that the numbers that we get, it is a farmer survey, so it is always going to be a bit of an estimate, and sometimes I think I heard that at lunchtime, the conversation is this is kind of a best guess, or this is what it might be, but these are the numbers that we got to run with. So I think they're, and then it's always going to be compared to what it was last year. So we're down a little bit on tons, and but an increase in acres. So they figure we're about 21.9 million acres, and then a yield at about overall average yield of 36.9 bushels per acre. And then if you look at province by province, so for Saskatchewan, over last year, the yield increase was a little bit less, coming at 34.8 bushels per acre, with more acres, so just about 12.3 million acres in Saskatchewan of canola. And in Alberta, our production fell from last year about 3.5% to that 5.4 million tons on 6.3 million acres, giving us the average yield of 37.9 bushels per acre. And Manitoba was a little bit higher for sure with on yield, about 43.2 bushels per acre, and both 3.1 million tons and 3.1 million acres. So that's where yesterday's numbers kind of came out, and I think it's interesting. I think talking with farmers and folks in the industry of what they think these numbers are, but that's kind of, I think it's gives us an idea. if we looked at what this was a couple months or a month or so ago, it was quite a bit less, and so they've give us an increase in the total production. And again, it goes back to kind of the theme of what the previous presentations, looking at that at the weather maps. And so if you look at what our prediction on outlook at the end of August, where the good crops were, and it follows that pattern of what we were seeing for typically the weather that we're experiencing during the growing season, and where it was not too bad, or is where we were getting a little bit of moisture and maybe not some of those extreme temperatures. I know where we were. I'm up in the Peace Country, and so we were experiencing the fires and the smoke right in our backyard. So it was kind of a season-long thing where we were getting that effect from the fires, but it definitely worked its way across the country, and then even to hear folks in the U.S. talking about the effects of the fires on some of their crops, it's still a bit not too sure if it was bad for or how it affected it. And then again, for the predicted median canola yield at the end of August, where those numbers were coming from. So definitely the going back to what we might have had for some residual moisture, or where the lack of moisture during the growing season wasn't as big of an effect. We were still getting some potential increase in the canola crop, or yield on the canola crop. So if you look at that overall, the weather story, and I think that's something that we've talked about quite a bit, having those dry conditions at seeding time, and with some relatively low soil moisture levels in the majority of those seasons, and then pretty early start, being fairly warm at seeding time. I know we were getting some 30-degree days even in the Peace Country at seeding time, so things were pretty warm and drying up quick, so it a little bit slower to start. And then of course, as we had those conditions, it was pretty good for wildfires to start. We were seeing very low humidity. So when the humidity was lower than the temperature, the air temperature, it was starting those fires pretty quick. And I know I was out soil sampling the one day on May the 5th, and I wasn't sure if I was going to be able to make it home that day, because I was driving with fire on both sides of the road on my way home. And those were fires that, they weren't part of any big forest fires. It was just grass that was starting to catch on fire on the side of the road and spreading across fields. So then we go to our summer conditions. We did have a lot of those drier conditions in the brown soil zone as well, including up in the Peace Country, and we did see some of those conditions giving us an effect on the crop. So we did have some of those high temperatures during that flowering period of the canola, and it, even if there were some areas getting some moisture, it was pretty isolated in where the canola was being grown in that part. And again, looking at those soil moisture stats on where it was dry in that mid-June, so things were looking on the dry side. We did see later in the summer, so earlier in the fall, we did get a little bit more favorable conditions. And so again, talking about how early the harvest was starting, so we're starting to see harvest happening fairly early across some big areas. And then again, just that weather conditions. So as far as the other issues that were going on in the crop, some of the yield robbers that we were seeing, some of the disease, we did have reports of verticillium stripe being found in that central Saskatchewan area, as well as pockets of Manitoba that did receive some adequate rainfall. Not as drastic as it was reported in 2022 following the wet season, but we had growers and agronomists scouting and sending samples for testing, and we encourage people to do that to identify that disease. And then again, despite the dry year, there was blackleg presence was fairly high, even in the brown soil zones of the prairies. that experienced some of the drought during the growing season. And like 2022, disease scouting and conversations indicate potential high levels of blackleg again. So due to the dry conditions, threat of clubroot was not as much of a main concern, but you know, again, with it being in the soil, it's, you know, always going to be a potential for that disease and additional spread. Cutworms, as an insect pest, were reported in some pretty high populations across regions of Alberta, and I know of quite a few fields that had to be reseeded in that Calgary and up in the Peace River region. It's you know, stories from growers, they had gone out to do their first pass of herbicide across that field and there was canola there, but then later on, or going back, you know, a few days later, and there was no more canola plants, so kind of wondering what was going on, and it tended to be a cutworm infestation. And you know, we did have reports of flea beetles in some areas, not as to the extreme as it was in 2022. Grasshoppers, again, another, you know, related more to the dry conditions of the prairies. So potentially, you know, that's going to be another year next year for grasshoppers as well. And then weeds, you know, obviously we've had that conversation about some of the weed management. So kochia being able to thrive and grow quickly, even with warmer, drier conditions, and without a lot of crop competition, could establish itself and use up some of those nutrients and moisture in the field. And you know, so I think if we look at some of the other yield robbers that were potentially out of our control, we did have some reports of aster yellows in all three provinces, as well as a little bit of the canola hormonal imbalance system, so where we would see the flowers not turn into pods on some of those plants, and so something that, you know, not necessarily under our control to manage. And so, you know, I guess with that wrapping up, I know we've had a really good conversation so far on that theme of the weather, and I'm around for questions or conversations the rest of this week. So thanks very much.
Thanks, Jason. And if you have questions for Jason, be sure to catch up with him after 4. So we're going to move on to our next speaker, who is Dr. Meghan Vankosky, who is a field crop entomologist at the Saskatoon Research and Development Centre, and she's also chair of the Prairie Pest Monitoring Network, and we're looking forward to her presentation on the Prairie Insect Update.
Thanks, Sally, and thanks everyone for sticking through the afternoon. Get the slides up, excellent. Okay, so I'm going to talk about canola insect pests. And I really don't have to talk about the weather because everyone in front of me already has talked about the weather, but it is important for insects. Insects tend to respond either very well or not so well to hot and dry or cool and wet conditions. So keep in mind that the growing season in a lot of places got off to a very hot start and was generally warmer than average. And in terms of precipitation, we kind of had these areas of have and have not. Some areas were quite wet over the summer, not necessarily at the right times, but then other areas were very, very, very dry. So the Prairie Pest Monitoring Network monitors a number of different canola insects. We're watching out for Bertha armyworm, cabbage seed pod weevil, grasshoppers, diamondback moth, just to name a few, and I'm going to kind of cover what happened with those species in 2023 in the next 7 or 8 minutes. We cover a lot of area over the course of the growing season, and thank everyone who has contributed to this data set. We do not do it ourselves. It's a very highly collaborative team, and a lot of people share access to their fields or share data or supervise traps, and that's very important to establish, again, these long-term data sets so that we can start to look at trends and see what's happening over time. So thank you to everyone who contributes to the Prairie Pest Monitoring Network. Without you, we could not give this presentation. So in terms of kind of a good news story, we have not had a Bertha armyworm outbreak on the prairies for quite a number of years now. We've kind of all been waiting for a Bertha armyworm outbreak, but cumulative trap counts for the pheromone trap monitoring program were very, very low across almost the entirety of the prairies in 2022. This is still the map from 2022. But we saw the same in 2023. There were very few places where we saw any numbers into that concerning or potential risk area for Bertha armyworm. Don't really know what's happening here, why we haven't had an outbreak. We're overdue for an outbreak. We don't want one, but it's like, what's happening? We really don't know, so we just keep monitoring for them so that we can be prepared if the numbers do start to increase. The cabbage seed pod weevil is a bit of an interesting case where we have seen up until about 2016, 2017, the range was really expanding and we were seeing higher and higher population densities through more and more of the southern prairies and getting into the Edmonton area and the Saskatoon area. And then in the last few years, really with the drought, we've seen a contraction of that population. So the maps are there for the last few years. The map for 2022, which we just finished processing our 2023 samples, so we don't have that map yet. The map for 22 is weevils per sweep, not weevils per 25 sweeps, but the message is still there that we really have seen this contraction back down to the south, and we really kind of saw that again in 2023. We didn't have many samples where we had really high number of weevils outside of the southern area. So we'll see what happens, but they don't really seem to like dry conditions very much, and so again, that contraction. Diamondback moth, there we go. As we know, they really aren't expected to overwinter in the prairies. Cold winters have some good points, but once we do have diamondback moth coming in, migrating in the spring, once they're present, then the warmer it is, the more generations they can have in a very short period of time, and the more risk they pose to our canola crops and other brassica crops as the season progresses. So in 2023, we were predicting that we could have seen 4 or 5 generations of diamondback moth after that initial adult population arrived. That's a lot of generations. Without a lot of weather events, heavy rainfall and hail, the larvae survive very well. And so we did see that the populations were getting very, very high in some areas through the summer. So all through the year, we're predicting the number of generations we could have based on the weather. And I hope that people were paying attention to us and going out and scouting for diamondback, because there was a potential to have a lot of them. And if we see the same warm conditions next year, once the population arrives, if they do arrive, then that risk is there again next year. I'm going to end with grasshoppers. I have a few slides to go through. I think I'm keeping pretty good time, so we might have time for questions. But in the last few years, we have seen that the areas of the prairies with higher grasshopper populations have been increasing. So again, this is the map from the 2022 survey. We had kind of in the south, high numbers. I think that this map kind of underestimates what was out there for grasshoppers in 2022. In the map for 2023 is a lot oranger and a lot redder in the south of Alberta and Saskatchewan, especially a little bit less in Manitoba. So that's a preview for the grasshopper survey from this year when our maps do come out. Grasshoppers got a great head start because of all of that really hot weather that we had in May. So we normally start going out to selected sites in Saskatchewan in that first week of May with our summer students, because we want to get zeros. We want to know that there's no grasshopper nymphs yet. Well, there were already grasshopper nymphs the first week in May. And so that just led into this long grasshopper season, and it's all I talked about. Trevor Hadwen, who we had the recording from earlier, and I had the most official media mentions in Western Canada through Ag Canada because of all of the interviews that we gave about the drought and about the grasshoppers. So we were very popular, but not for the right reasons. So, yes, we're seeing that grasshoppers are getting to be more and more widespread in higher and higher numbers on the prairies. We had grasshopper development almost 2 weeks ahead of normal in 2023, again because of that hot start in May. And so the maps here, one is from 2022, and one is from about the same time in 2023. And so in 2022, we were starting to see a few third instars, I think, on my map at that time. And at the same time in 2023, we were already seeing fourth and fifth instar grasshoppers. That meant that by June 15th, we had adult grasshoppers on the prairies, adult pest grasshoppers. That has not happened in over 35 years. I work with people who have been working on grasshoppers their entire careers, and in 30, 35, 40 years, they've never seen adult pest grasshoppers in June. So that's not good. It's weird, and it's a neat factoid, but it's not good. So grasshoppers, not cool. This particular picture shows a sweep of grasshoppers. So we went out with the sweep net on the side of the road. This was just west of Kindersley. We had 1,788 grasshoppers in that 25 sweeps. So that's 70 some grasshoppers per sweep. That bag weighed a lot when we brought it back to the lab. That's just like, that's all grasshoppers. So when we are saying that we had no canola samples sent in from the Southwest and Saskatchewan, that could be why, because Southwestern Saskatchewan RMs were a disaster zone between the grasshoppers, the prairie dogs, and the drought. Like SCIC wrote them off, right? It was that bad last year in 2023. So the grasshopper outlook going forward into 2024, because we have all this historical data and we know so much about grasshopper biology, if it stays as dry and warm as it has been, 2024 is looking to be, unfortunately, even worse than 2023 in terms of grasshoppers. So be ready, scout early. Grasshoppers are easiest to kill when they're small because they can't get away from the insecticides and it takes less insecticide to kill them. And you can treat the ditches or the field edges before they move into the whole field, and you have to spray the whole field. When grasshoppers are this desperate for food, they really like canola. They don't necessarily normally go for canola, but if it's there, they're gonna eat it in years when there are a lot of them. So I hate to be the bearer of bad news, but be ready to scout for grasshoppers in 2024. Which takes me into my outlook slide. Now I'm not so much on time because grasshoppers are just so interesting to talk about. If it stays warm and dry, grasshoppers are going to be on our radar, but it's really weather dependent. If all of a sudden it rains all spring, grasshoppers are gonna disappear, and then maybe we'll be dealing with wheat midge in our wheat fields instead. So anyway, that's kind of what happened with insects that we monitor through the Prairie Pest Monitoring Network in 2023. The provincial and regional maps are almost ready to be released, so please watch the provincial websites and the Prairie Pest Monitoring Network websites to see what happened near you. And thank you very much to all of the people who contribute and for your attention this afternoon.
Thanks, Meghan. So our next speaker is Dr. Jemanesh Haile, and she joined the Canola Council of Canada in June of 2023, just this year, to manage and coordinate the Western Canadian Canola and Rapeseed Recommending Committee, or the WCCRC. This is the committee that's responsible for recommending new canola and rapeseed varieties. So she's the new Raymond. In case you remember, that doesn't sound familiar to you, but you remember Raymond from other years. And I am going to take a couple of minutes to introduce Jemanesh because she is new to the canola community. So she has lots of experience coming from the world of durum, where she contributed to the registration of 3 durum varieties, and she has over 25 publications in peer-reviewed journals. And she holds a PhD in gene and genome mapping from the University of Kassel in Germany, and also a master's in applied genetics and a BSc in plant sciences from Ethiopia. So welcome.
Thank you, Sally, for the introduction, and I would like to thank the organizers for giving me this opportunity. Today, I will give you a few highlights about the changes for the existing canola verification system in Western Canada. For those of you who don't know about WCCRRC, like my first time for the canola, WCCRRC with the abbreviation stands for Western Canada Canola Rapeseed Recommending Committee. It coordinates the variety verification across Western Canada and recommends canola varieties for registration based on agronomy, quality, and yield attributes of canola. WCCRRC is administered by Canola Council of Canada and governed by a board of directors. The board of directors and the members involved in the WCCRRC involved all sectors of the value chain, including plant breeders, pathologists, seed growers, exporters, crushers, the Canadian Grain Commission, the Canadian Food Inspection Agency, and the Animal Nutrition Association of Canada. WCCRRC has also subcommittees, such as the Specialty and Contract Registration Committee, which review and recommends high uric acid rapeseed cultivars mostly, and the Pathology Subcommittee, which sets guidelines for canola disease and review each year the canola blackleg public trials, and the Quality Subcommittee, similarly, which sets guidelines for quality analysis for the canola varieties that are registered in Western Canada, and also other committees as needed. WCCRRC accepts data from trials conducted in Manitoba, Saskatchewan, Alberta, and the Peace Hill region of British Columbia. And the Western Canada canola growing regions are divided into 3 growing zones: the short season zones, the mid-season zones, and the long season zones. In 2020-23, as an example, Canola Council of Canada, on behalf of WCCRRC, coordinated about 1,500 trials across 128 locations in Western Canada, and 95 trials as a public or as a second-year verification trials on 31 locations. Data requirements for registration based on the validity of the tested data, as well as the interest or the plans of the developers. It might be an interim recommendation, or it will be a full registration. For interim recommendation, it's a minimum of 12 environments data that are collected over 1 year. For quality, for yield, and also for maturity if it is brassica napes, and also 1 year Blackleg data for information purpose. It is also important to disclose the herbicide-tolerant nature for herbicide-tolerant canola candidates. For full registration, it is important to submit data that are conducted a minimum of 12 environments for 2 or more years, out of which 7 environments verification quality data and 3 environments Blackleg data. Before I compare the current system with the system we are proposing to implement starting from 2020-24, the first year trials are conducted by developers themselves, but when we come to second year, the WCC RRC conducted Blackleg and yield trials testing for also quality and maturity and agronomic data collection. On the same year, the developers themselves, they also conducted a yield trial. And after that, the samples that are collected from the public trials that are coordinated by WCC-RRC sent to Canadian Grain Commission for quality analysis. After that, the data back to WCC-RRC and integrated with the previous private data, and based on that, variety recommendation will be performed. This is the system we have until 2020-23, but starting from 2020-24, there is no more yield testing that are or the public co-op will not be conducted by WCC-RRC. Rather, WCC-RRC only performed Blackleg testing, whereas the developers, they performed the yield testing and sent the samples for quality analysis to Canadian Grain Commission through WCC-RRC. By doing this, we are increasing the number of candidates to be tested. As you have seen here, it is 80 here, but here it is 140. So simultaneously, we are increasing the number of cultivars to be released. And also we avoid duplicate yield testing by WCC-RRC and also by the growers. But the same quality testing and data integration will still continue with Canadian Grain Commission and WCC-RRC. When we come to the due dates, if a developer interested in interim recommendation, the data submission for interim recommendation is December 15, and in March, the developers need to submit their Blackleg entry list for the coming year and asking for check seeds because we distribute check seeds that are homogeneous to all the developers. And also entry seed has to be submitted for those Blackleg entries that are submitted in March 15 by March 31. And also all the due dates are accordingly will look like this. We need, WCC-RRC will ask still spot inspection for the private as well as for the public co-op. And also it is important to report the canceled trials due to any reason, whether it is private or a verification trial for second year. And also after sending quality samples, it is also important to submit the summary, CV, and ANOVA for the verification trials for data integration with that we received from the quality data from Canadian Grain Commission. In terms of costs, a new fee cost is $3,200 per entry. What I want to specify here is that to enter fall variety verification trial, it is mandatory to be involved in the public Blackleg testing. So this cost breakdown is not only for Blackleg testing, it is also includes administrational, computational, disease testing, quality analysis, and also spot inspection by WCCRRC. With this, to summarize the new system, well, that means the modernization with WCRC, it avoids yield trial payments by growers, and also still Canola Council maintain the oversight, and WCCRRC coordination will be still maintained. WCCRRC still secure and maintain and distribute check seed, and coordinates the Blackleg testing, yield test, and quality testing, and also spot inspection, and also data integration and data summary for registration. Canadian Grain Commission maintain the quality analysis with a workload of 2,400 to a maximum of 2,500 samples per year. With this, I would like to thank the Modernization Committee who are involved and taking their time to review this system, and also our administrative assistant, Cheryl Kiefer from Saskatoon, and the previous WCCRRC coordinator, Raymond Gadwa, and Canola Council of Canada for administration. And thank you all of you for your attention.
Thank you, Jemanesh. So that concludes our presentations this afternoon. I'd like to thank everybody for your attention, and thanks to the speakers for the great talks, and apologies there hasn't been a lot of time for questions, but hopefully there's lots of time for good discussion in a few minutes.